So in this experiment, we're going to use the wave equation c equals lambda f to work out what the speed of light is, because the microwave here will send off sort of waves at a certain frequency, which is written on the back of the microwave. So that gives us the f. And then we can measure the wavelength where the points where it melts. And so you can see from this diagram here that as the microwave goes across, the antinodes are the cold points, and the parts where the wave goes up and down, oscillates up and down, oscillates the molecules in the food and makes it melt. And so the distance between two of those points is half a wavelength. And if you double that, well, the distance between 3 points is the full wavelength, so that's lambda. So you can times those two together and you get the speed of light. And so what you can see here, and so here's just a diagram of how it works, and this is someone with an infrared camera can show you where the nodes are, and so they're evenly spaced across. So it's not perfect because the waves, it's three-dimensional, and so it's not just a nice straight line that's going across. So when I actually did it with my real microwave, which is sort of a newer one and not the cheapest one, it was just giving me one heating spot right in the middle right there, and I thought, oh, okay, this is why we paid so much for this microwave. The engineers have worked out how to focus all the waves in the middle, rather than these older microwaves that have it all around the edges, and you have to turn the plate around. This one you don't. It just sits. It's just nice, straight and flat, and it heats up directly in the middle. But I did get the second one to come off slightly, so there's just two spots in the middle where it heats. That first one's smack bang in the center though, and so thankfully I could still use a newer microwave. So here we are zooming in on it. So that only gives me a half wavelength to measure, and I think conservatively I'm going to go plus or minus half a centimeter, because that blotch, that's somewhere in the. I'm pretty confident the center of the blotch is about 6.5 centimeters, but I have lined up the initial 0 as well, and so I need to double the uncertainty. So there's a 0.5 uncertainty at the start and a 0.5 uncertainty at the end. And I have to double the whole thing again as well. So I've gone for 13 plus or minus 2. And so if you divide 2 by 13, that gives me a 15% error, because I'm going to times out in a second. So pretty much all the microwaves are 2,450 megahertz. So that's another 6 zeros on the end. Mega's a million. So that gives me 2450 with 6 more zeros hertz, getting all back to standard units. And so that works out to that big number there, which is 3.2 by 10 to the 8. So the answer is 3 by 10 to the 8. So I'm 2.7 to 3.7. So we got the answer within our uncertainty. So success.